In imperial units, follow with me just for a moment. The imperial pressure scale is based on atmospheric pressure. Positive pressure rises in pounds per square inch. So here we go. Here is a compound pressure gauge. So zero pressure, the pressure that we feel in this room is zero pressure. And this is 5 psi and 10 psi. But the pressure that we feel in this room is not zero pressure, it's atmospheric pressure. So then this would be 10 inches of mercury, 20 inches of mercury, and 30 inches of mercury. This is the way that your pressure gauges read. Here we have inches of mercury, and absolute zero pressure is 30 inches of mercury. Now, does anybody know the real absolute? It's not 30. It's 29.92.
That's zero.
But see, if we just say, screw it, call it 30. Okay, screw that. Nobody can work with 29.92, especially in these days of calculators. Can't even balance the checkbook anymore without a calculator, okay? So it's a 2-to-1 relationship. Look at this. Total vacuum, look at the space that it occupies on this gauge. Total vacuum is the same as 15 psi. This distance from here to here is the same as that distance from here to here. And it is a 2-to-1 relationship. 10 inches of mercury, it would be the same as minus 5 psi. 20 inches of mercury would be the same as minus 10 psi. And 30 inches of mercury would be the same as minus 15 psi. If the engineer does not understand this, how can the operators and the mechanics understand this? If the operators or the mechanics come to the engineer and they say, I need some guidance here, what are you going to do? Then negative pressure in the imperial scale begins at atmospheric pressure, and it counts backwards. So that's it, because it counts backwards toward a total vacuum of 29.92 inches of mercury, which is also called 760 millimeters of mercury. And there we see it right there. So this is the zone for vacuum, and this is the zone for positive pressure. And here we see an actual gauge. There's your zeros, 10, 20, 30 inches of mercury, and then 10, 20, 30 psi on this gauge. Now, if we're going to get our pumps under control, if you want to stop chasing vibrations, you want to stop chasing cavitation, you want to get your pumps under control, we're going to have to get this under control. There is an answer in the metric system. I'm not going to say convert to metrics, but there's a way to do it. In the chemical process, petroleum mining, or refining industries, the metric unit kilopascal dominates. Because kilopascals start at absolute zero pressure, and the kilopascal scale rises to 100 kilopascals at atmospheric pressure. The kilopascal scale effectively divides atmospheric pressure into 100,000 units, which would be 100,000 pascals or 100 kilopascals. That's atmospheric pressure. In the metric system, zero pressure is 0 kilopascals. Then we have the world of vacuum. Then we come to the pressure that we feel in this room, which we call atmospheric pressure. It is 100 kilopascals. And then positive pressure is above 100. Vacuum is less than 100. Zero pressure is 0 kilopascals. This is one reason to consider the metric system. But what you might do, as the engineer, is start purchasing what you call absolute gauges. Because on an absolute gauge, 0 psi is 0 pressure. The pressure that we feel in this room would be 14.7415. And teach this to the people. But it is impossible. You cannot determine the pressure without a calculator and some knowledge of what pressure and vacuum is. If you go by inches of mercury or millimeters of mercury and pounds per square inch. Nobody in the room could answer the question. Not technician, not engineer. Don't worry, it's like this in every class. It's like this in every class. The simplest, basic reading a pressure gauge is beyond our control. We got to get that under control.